Good day. Now let's work on a continuity question. And we want to determine the value of k so that the function g of x is continuous everywhere. So the most important condition that we need to satisfy here is that the limit as x approaches -1 of g of x is equal to g of -1. And of course, the two other conditions are that first, this must exist, and second, that also needs to exist, essentially. So those two conditions are, of course, pretty important. And the third one is that once we make this happen, the function will be continuous at x equals -1. And, okay, so let's try to evaluate this. Limit as x approaches -1 of g of x. And how can I figure this out? Well, when x is not equal to -1, so both to the right and the left of -1, g of x is just going to be equal to this. So I can actually just evaluate the limit of x squared minus 1 over x plus 1. And I'm going to graph everything as well so that it makes great sense to everyone. And here I can actually factor x squared minus 1 as x plus 1 times x minus 1 over x plus 1. Those two cancel out. Then I'm fully allowed to plug in the -1 right here. So -1 minus 1 is -2. Great. So that is the limit as x approaches -1 of g of x. So -2. Just use a different color here. And okay, so now actually I'll just start graphing things as well. Note that we had just x minus 1, right? Whenever the function was not equal to -1. So that's just a straight line here with an empty dot at x equals -1. Let's pretend that this is straight. Well, not even close. Okay, that's acceptable, I guess. And it has, so it's a linear, it's just a line, right, passing through -1, because that would be y equals x minus 1 with a slope of 1. So far so good. But now we have this empty dot here, and we need to fill that in with a value of k that would make that happen. And how can we make that happen? Well, we need to make g of -1 equal to -2. And what is g of -1? Well, when x is equal to -1, g is equal to 2k. So 2k needs to be equal to -2. So now I can just divide both sides by 2. And k will be equal to -1. Great. So now when k is equal to -1, and that basically answers our question, this dot here, this empty dot gets filled up, and the function is actually continuous everywhere because of the fact that this line is indeed continuous everywhere. Polynomials are always continuous everywhere. Our only concern was really to fill this point in, thereby the function's continuous everywhere. So hopefully this made good sense to you. If not, I'd suggest you check out some more questions. Good luck.